Have you ever had this experience? You get home late due to an overtime meeting, and the rain outside just makes you feel more tired. All you want to do is sit back in the couch and relax with some lo-fi music. However, the music in You Might Like playlist start to recommend some rock and roll music, which you usually enjoy when you hang out on Saturday, but it just don't fit your mood right now. This is actually what happens to our recommendation system. The recommendation systems nowadays are highly rely on users' subjective feedback, meaning that users need to rate their feeling about the song and the videos manually. Sometimes users cannot find where to rate or just being lazy. The rate is then missing and the recommendation systems learn nothing. The situation becomes worse as the age of the users increases. Elder people usually suffer from blurry eyesight and degradation of learning ability, making them more difficult to find where and how to rate. To make the recommendation system more user-friendly, our team proposed an automatic biosignal-based recommendation system, QPlay. QPlay records users' brain signals while watching the videos. With these brain signals, QPlay classifies the user's preference toward the videos and learn what video should it recommend next. What do the user need to do? Nothing. Just grab some popcorn and enjoy the good vibe. Sounds like magic? Let's take a look into detail about how QPlay achieves this goal. First, let's talk about how QPlay classifies the preference from the brain signals. Using a cap with electrodes, QPlay is able to record the electroencephalogram, aka EEG signals, from the users. Next, QPlay calculates the distribution of band power on scale for different frequency bands. The band powers are color encoded into one figure and sent into VGG16 for feature extraction. On the other hand, QPlay also calculates the conditional entropy for each electrode pairs as features. Both feature sets are down selected by PCA, and finally, QPlay combines these two feature sets and classifies them into like, dislike, and neutral using an ELM. These preference labels will be sent to the recommendation learning and the second element of QPlay. Now we know how QPlay classifies the preference. Let's talk about how QPlay recommends a good video. QPlay uses a reinforcement learning method called Q-learning, which is how it got its name. In the Q-learning process, QPlay takes the current video index as state and the preference label as reward. The mapping between preference label and reward is shown in the left-hand table. With this information, QPlay can find out the most preferable playlist and choose one video from the playlist to recommend. This is the whole Q learning process on the FPGA. In the beginning, all Q value is 0, so we choose the first random action to output. Then we wait for the reward. After the reward comes in, we can calculate the new Q value, update our Q mask cache and Q table, then output next action. Let's take a closer look at the hardware architecture. There is one unit which makes the QPlay unique, the Q mask cache. The unit can prevent unnecessary comparison by storing the largest Q value and corresponding action. Also, we don't need to read all Q value of a state from Q table, since we don't need to compare them. Hence, it can reduce SRAM access and speed up the whole process. We simulate 100,000 times of learning process, and we found the Q max cache can reduce nearly 50% and 33% of computation time when we have 4 and 8 playlists respectively. Next, let me demonstrate how QPlay works. Here, we simulate a scenario of a new user using QPlay. First, the user will look at the video. And QPlay will classify the user's preference by EEG signal. In this case, the user seems to like the video he or she is watching. Next, QPlay will find the next video the user might like. With the result we have got, we believe QPlay can improve users' experience by minimizing the need of subjective report and giving the right recommendation in real time. I'm glad to introduce QPlay to you, and I hope you are as excited as we are. Thank you for your interest in QPlay, and see you in the future playlists.